Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Before we start this experiment, let me introduce myself first. My name is Dwita as the assistant for this experiment, and the title of this experiment is Solute Distribution between two unmixed solvents. The aim of this experiment is to determine the equilibrium constant of a solution for two immiscible solvents. In this part, I will explain about the basic theory of this experiment. So, basically, this experiment applied the technique of the liquid-liquid extraction. And what is the liquid-liquid extraction? It is a separation process consisting of the transfer of a solute from one solvent to another, and the two solvents being immiscible or partially miscible with each other, per 2018. Also, this experiment using petroleum ether. What is petroleum ether? It is a substance which colorless and strong odor. And I will tell you that something important, that this substance is volatile and flammable. So make sure you wear the standard of PPE or personal protective equipment. And this experiment using the principle of equilibrium constant theory, which the equilibrium constant theory is a numerical value that characterizes the relationship between the concentration of reactant and product in a system at the chemical equilibrium. Stoker 2012. As we know, to do the experiment, we have to use the PPE, or personal protective equipment. These are the PPE list. There are lab coat, goggles, mask, and gloves. There are many tools and materials that used in this experiment. The tools that used were burette 50 ml, clamp and stative, separatory funnel, Erlenmeyer, picker glass, graduated cylinder, drop pipette, pipette pump, volumetric pipette, funnel, and volumetric flask. Meanwhile, the materials that used in this experiment were sodium hydroxide 0.5 molar, acetic acid 1 molar, petroleum ether, phenolphthalein indicator, and aqueous. In this part, I will give you the outline of the experiment. So, basically, the first step we will do is making the mixture of the solute and the solvent. Then, this mixture will be divided into two parts. Each part will be done separately. The first part is the solution will be titration to get the real concentration of the solution. And the second part, the solution will be extraction and then titration to get the concentration of solute in the solvent. So, for the whole process, the first part must be done first and then continue with the second part. Then comes to the work section. This is the first step of the experiment. In this part, the dilution process was conducted for some concentration, wherein take 1 molar of acetic acid and aqueous into the 50 ml of volumetric flask. Then shake it until it becomes homogeneous. But the question is, how much did you take the acetic acid? So, make the calculation first to calculate how much do you take the acetic acid. Use the ordinary formula for the dilution to get the volume. And each dilution was conducted separately in order to get some concentration of acetic acid. There are 0.2 molar, 0.4 molar, 0.6 molar, 0.8 molar, and 1 molar. And the dilution is carried out from low into high concentration. And make sure the solution must be homogeneous. This part is the crucial part, where for each concentration of acetic acid from the previous step was divided into two-part treatment. The first part, the solution will be titration processed directly. Meanwhile, the second part, the solution will be undergo extraction process. And in this slide, I will explain the first part. In the first part, take 10 milliliters of the solution and add it with 2 drops of PP indicator, then titrated it with 0.5 molar of sodium hydroxide until the color of the solution changed into light pink. And the titration process was repeated 2 times, and note the volume of the titration. Note the volume of the titration as VA. In this slide, I will explain the second part. In this second part, 25 milliliters of acetic acid from the beginning step and 25 milliliters of petroleum ether were poured into the separatory funnel. Then, the separatory funnel was shaken until the gas disappears. Make sure the shaking process was done in a fume hood or near the window, and you must use full of PPE or personal protective equipment. And let the separatory funnel for a while, maybe 5 or 10 minutes, until it forms 2 layers, wherein the upper layer is the organic phase and the bottom layer is the water phase. Then take the water layer by put air layer under the separatory funnel. This slide still explains about the second part, which it is the further steps. After you get the water layer from the previous step, take 10 milliliters of it and pour it into the air layer in order to do the titration process. And added 2 drops of PP indicator into it and titrated with 0.5 molar of sodium hydroxide until the color of the solution changed into light pink. And the titration process was repeated 2 times, and note the volume of the titration. Note the volume of the titration as VB. And arrived to the experimental data. So, after the experiment was done, we got some data of volume titration. These are the data of titration part 1 and part 2. As shown in the information, VA is the volume of initial titration or part 1, and VB is the volume of titration after extraction process or part 2. As remember, each titration process was repeated twice. Therefore, there are VA1, VA12, VB1, and VB2. In this slide, I will explain about the sequence step for the data processing. The first line shows how to calculate the volume average for each titration. Use this formula and get the volume of average for VA and VB. Next, the second line shows how to calculate the concentration of initial and the concentration of water. Use this formula and get the concentration of it. Don't forget, use the volume of average. Next, the third line shows how to get the concentration of organic. Use the simple formula and get the concentration of organic for each variant acetic acid. And the last one shows how to get the graph of it. By calculate all of this data and then you get the concentration of organic and concentration of water, you can make it into ln concentration organic and ln concentration of water. And then you can get the graph of it. This slide shows the data processing result. After you calculate all of the data and then you get the V average A, C initial, V average B, C water, C organic, ln C water, and ln C organic. And arrive to the further data processing result, which is it shows the graph of the data. By calculate as the calculation in the slide, you will get the K value. I will explain it in detail when the online experiment. Congrats, you have seen this video until the end. Sorry if I made any mistake. Thanks for watching this video and see you on the online practicum.